Okay, so here is the review session. I have put together some slides, essentially talking about the logistics for the exam, and then depending on how much we have time left, I plan to do this for 1 hour, and in the remaining time, I will take your questions. So, when is your exam? It's on Thursday. That's day after tomorrow. We have two time slots. I have arranged for a sign up on Gradescope. Almost all of you have signed up for this, but there are still some students who haven't signed up. Please go to Gradescope. It will take you 5 seconds to do this. Just go and pick an option so that I know which exam room link to send you. So I will be sending an email tomorrow, which will have a WebEx meeting link for the exam time you sign up for. Please do not go to the regular class link. I will send you a separate link in your email. Expect that email tomorrow. So two time slots. One is going to be in the regular class time. That is from 10:30 a.m. to 12:30 p.m. Eastern. So 2 hour time slot. We are extending the regular class time by a few more minutes so that we can get a full 2 hour slot for the exam. The other option is from 9 p.m. to 11 p.m. the same day. 9 to 11 is that's based on the Eastern time zone. You see these options over here. And as I said, during the regular class, we did this little exercise where I sent you guys a file which had exam one topics. That's exactly how I plan to send you the exam. So once you join your respective WebEx meeting link, and the link will be made to you, made available to you in your email. Once you join that, just before the exam time slots starts, I will transfer the exam one PDF to you. Um, Links of the WebEx meeting will be emailed tomorrow before 6 p.m. Eastern. Next, when you are at the end of your exam time, I am providing a recommendation about what I feel is a good, safe time to complete scanning and uploading. So, last 20 minutes of your exam time, please use that for scanning and uploading of pages. Upload the pages and then map pages to problem numbers. You guys are experts at this by now. And then after submission, just go back and check the submission if the submission went through okay or not. And as you know, the Gradescope submission will automatically close at the due time, depending on which time slot you sign up for. So after you submit, just go back in there, check it, but also be careful that you don't go over time. In my experience, it takes about 11 and a half to 12 minutes on average to scan 10 pages and upload to Gradescope. That's an average in my experience. So to be safe, I'm going to recommend 20 minutes. And because you do this for homeworks, I hope that all the scanning and uploading logistics are set for you. So because I don't want you guys to stress out about this. Okay, that's just a recommendation. It's not a requirement. The only requirement is you need to get it in before the due time. Okay, let's. I have other recommendations that will come in later, but right now it's just the Gradescope uploading times. So what's allowed during the exam? You're allowed to have a hard copy of books and notes. These can be printed, these can be handwritten, but they need to be physical hard copies. You're allowed writing supplies. You are allowed to use your primary computer, which is most likely your laptop, or in some cases it might be a desktop, but you can only use that to view exam questions in the case that you do not have access to a printer. If you have access to a printer, I will make the exam available to you a few minutes before the start time, so you will have some time to print it out quickly. If you don't have access to the printer, you can use your laptop or desktop to view the exam questions. So scrolling up and down through the exam is allowed. If you have any question during the exam, please type that in the chat box privately directly to me. And I'm going to be monitoring it all the time. So I'm going to uh, respond right away. And then you're also using the primary computer for proctoring purposes. So you can use a webcam or whatever camera that you might want to use so that we can proctor the exam. What is not allowed during the exam? A calculator, iPad, or a tablet, your phone, or any other electronic device is not allowed during the exam. We have talked about these things in the previous class. So let's move on. How is the proctoring going to work? Well, you will be required to join the WebEx meeting 15 minutes before the start of exam time for online proctoring. And this is a strict requirement that the meeting is going to be open way ahead of time, and you can join in. You're required to join in 15 minutes ahead of time so that we can get set up. Links will be emailed to you for your respective time zone, time slot. Again, I'm repeating myself, but there are some students who haven't signed up yet. Please take 5 seconds and sign up on Gradescope. That sign up is available until 11:59 p.m. Eastern tonight. So when to expect the email about the WebEx meeting link? That's going to be before 6 p.m. tomorrow. So I will compile the list of responses into two time slots. I will make two exam rooms, WebEx meeting exam rooms for those two time slots, and then I will send you the respective links. So keep an eye out for an email from me. This information will not be on Piazza. It will be directly in your email. So the reason why it's in email is because I want you to keep that information to yourself. Next, you will be required to keep your camera and microphone turned on during the entire duration of taking the exam. And once you're done taking the exam and you have scanned the things, you have uploaded the exam to Gradescope, you can leave. You can leave the WebEx meeting, and you can also turn off your camera and microphone after that. As far as your computer volume is concerned, please mute that so that you are not able to hear any noise on the channel, because a variety of students take the exam in a variety of conditions, so there might be background noise, and I don't want that to be of disturbance to others. Okay. How about during the exam? You are required to use your own paper and writing supplies, uh, and I recommend that you use one problem per page. You can go more than one problem per page, but I just recommend this because scanning and uploading might be a little bit easier to do it that way. But that's just a recommendation, of course. During the exam, if you have any questions, type in the private questions directly to me. I said that already. On your answer sheets, please write your name and page number on each page, and also show your work and answers clearly. So in some cases, you will be asked to sketch things. Please draw the sketches clearly, label the axes, label some important points. So the responsibility of presenting your answers clearly falls on you. Um, so show your work as well. Now, in some cases, you might have a very elegant way of showing your work, right? So, for example, if you reach your answer by just thinking about it, I would expect that you write a statement at least to that can count as showing your work, right? That statement of explanation can be of a one liner or two liner, but I want you to support numbers that appear on the exam with some explanation, with some justification. All right, that's as far as during the exam is concerned. Uh, let's see. So next we are going to move into the content, but let me take a pause here and see if you guys have any questions or concerns. If I use Cam Scanner app to scan my exam phone, yes, Jerry, that is okay. So once you are done with the exam, you can use your phone only for the purpose that you are using the Cam Scanner or any other application that you might choose to use. That is okay. How will you make announcements to all students during the exam if needed? I will post that as a uh, chat question, but I'm spending a lot of time proofreading these questions, and the only uh, I anticipate only a clarification that you might need, but from my end, I am paying this a lot of attention. So hopefully I don't have to make any announcements during the exam, but if I do, I will use the chat box and it will go out to everyone. Ryan says, is the 15-minute before strict time? My class before normally runs late. The 15-minute time is not strict, but to set things up properly, um, I think if you can join in early, it will help the setup a great deal. So even if you cannot make 15, if you can make 10 minutes, I will take that. Let's see, can I use my phone if I don't have a camera? You can use your phone in that case just for the sake of proctoring purposes, nothing else. I think you can do. Um, T, you are right. I can share the iPad screen, but I don't want too many resources being used during that WebEx meeting. So I'm going to only have one. Uh, I'm going to only join through one device, and uh, as I said, those announcements, if they go out, which I absolutely don't anticipate happen, even if even if there is a 0.1% chance of that happening, if it happens, please uh, check the chat box once in maybe half hour, to see if there are any announcements. Sander, I'm going to spend a little bit of time talking about the format of the exam, but I want to get through the logistics related questions first. Oh no, no, Alex, headphones and earbuds are not okay. Yeah, Alex, it's a very difficult thing, but I want to have rules that are consistent for all the students. Um, so I would consult with family members and have a conversation ahead of time, today or tomorrow, about you getting some quiet time during those 2 hours. All right, other uh, logistics related questions. Okay, so I believe we are okay in terms of logistics. Okay, uh, let me get into Sanders' question about the format of the exam. Before I go on to content, let me tackle that because you have asked for that first. Before, yeah, okay. So I can say format over here. So if you think about how much time we have, I believe, let's see, zero point 0.6 is okay. So 2 hours in total. That means that for the exam we have 1 hour 40 minutes, right? Instead of that, I can say 1 hour 40 minutes. The 20 minutes, last 20 minutes, you are essentially using up for your scanning and uploading. Now, the format of the exam is going to be in two sections of the exam. One is going to be short answer questions, and you can expect about around five questions here. And um, these are not multiple choice. These are short answer. What does that mean? That should take you as an approximate about 5 maybe 5 to 10 minutes to solve this question. No, I'm going to intend it to be less than 5 minutes. But the reason why they are called short answer is because you can, in some cases, you can just think of the reasoning, think of the logic, and be able to answer the question. Um, so it shouldn't take you too much time, but please show the work for this. There will be partial credit that applies for the short answer questions. There is partial credit. Next, we move on to the long questions, long answer, or we can call that free response. They are all free response, but these are longer. And you should expect around five questions here, maybe four or five. And this is where you will have parts involved. So there will be part A, part B, and the question will be broken down into smaller parts. What else? Yes, there is partial credit here. What else? And these are going to be written, maybe 15 to 20 minutes. um, this is more towards the 5-minute mark. These should more or less take about 15 minutes long. And in terms of all types of questions, I can tell you this: depending on what approach you take to tackle a problem, you might get done with it in 1 minute, or you might get done with it in 20 minutes, or you might take longer than that. So, your approach to solve the problem dictates directly how much time you are going to take to solve the problem. And I can give you an example of how this can this will be true slightly later. All right, Justin says part B relies on answer from part A, and yeah, you know Justin asks a very fair question. If the mistake is something that is carrying over from previous parts, will that be penalized or not? Well, first is this: I'm writing questions in such a way that you should be your part A, part B, part C are uh, my I'm attempting to make them more independent. That's one. Two, while you are solving the problem, keep in mind that your part A might be incorrect. So try to take information directly from the main question itself. So uh, so if you do, so like I said, I am taking some responsibility of that not to happen by forming questions, or at least most of the questions, in such a way that there is no interdependence between the parts. But even if there are some questions where there is, try to go for part B directly from the problem, the main problem layout, as opposed to part A. But in the case where you absolutely have to use the answer from part A and it affects part B, then I will not be penalizing the error. So if the error carries over, it should not be penalized. And I'm very aware of this, and I'm trying to form questions in it to not let that happen. So I hope that was helpful, Justin. Other questions? So you're talking about the format here: short answer, long answer. The short answer questions should be, maybe a little bit of arithmetic, a little bit of work, or just think about it, or so it should not take you too much time or work to get to the answer. But there is partial credit. Please show your work for all the problems. They are the only reason why I'm separating them into two sections is because one is meant to take you less time than the other. Now, even the long answer questions, for students who have a very intuitive understanding of, say, superposition and convolution, impulse response, response of LTI systems, if they understand that really well, how to go between one to the other, then even the long answer questions might take them even fewer than 15 minutes. So it really depends on the approach you take to solve these problems. Um, okay, so I hope that answers. You know, if you're curious about how the regular exam goes, uh, in the regular semester, uh, the in-person exam goes like this. This is just to see, just to show you that these are the kind of things I took into consideration while forming the format. So there are generally 10 short answer or multiple choice here, and there are usually 6 long questions here. So I went from 10 to 5 short answer, and I went down from 6 to about 4, and depending on the length, I may add a problem. So 6 down to 4 or 5, and we still have the same 2 hours. So I'm trying my best so that time is not uh, an issue. But you should also be aware that there will be, in general, I am saying this, that approach matters. All right. Other questions about the format? So if you're just joining the session, um, I'm saying 1 hour 40 minutes for writing the exam. The remaining 20 minutes, my recommendation is to scan and upload things on Gradescope. This is a recommendation: scan/upload. Again, recommendation. All right, let's see here. Um, the next couple of slides here are just detailing the same exam one topics document that I posted on Piazza. We have lectures 1 through 7, homeworks 1 through 7. Please take a look at the homework problems, and if there was any question, any problem that you had difficulty with, go and look at the solution. um, the solutions are pretty detailed. The steps are laid out in a very progressive, one after the other manner. So you take a look at the solutions and focus on getting those homework problems. You know th- those are essentially practice, right? So I hope that your practice goes really, really well. um, of course, there is lecture material, and the lecture links, the video links are posted on Piazza. So if there is any topic that you want to review, please go to those video links and watch them in 2x speed, if time is critical. But here are the topics. First, we did signal classification. We tried to classify signals into continuous versus discrete, analog, digital, periodic, aperiodic, causal, non-causal, energy versus power, even versus odd. So, classifying signals is one thing, but we also spent some time on finding the energy of signals, finding the power of signals, finding the even and odd parts of signals, and also determining whether they are periodic, aperiodic. Some of these you can do just by inspection, just by looking at the signal. Some you will have to do some calculations. For example, for energy and power, you will have to compute its energy. If it is finite, then you can classify that as an energy signal, and so on. So that was signal classification, and this was essentially, some of these topics were very generic, and the understanding of these topics carried forward with other concepts, but that's where we started. Then we went on to signal operations and representations. The common signals that we looked at where unit step, ramp function, gate function, impulse, the sinusoidal function, real and complex exponentials. So those were all the common signals we looked at in various different forms, right? We looked at, let's see here, I can say bracket notation, and of course we sketched it, and we also expressed it as a complete function, right? What I mean by complete function is simply one function of time. So, for example, instead of saying, let's see, t for time greater than 0 and 0 otherwise, I could say t u of t, right? So, t u of t is what I'm calling a complete function. And this, I'm calling it the bracket notation. And of course, if you sketch it, that's the sketch. So while we were doing these common signals, we looked at all these various ways to express them. Oh yeah, I wrote that over here. Representing the discrete or continuous time signals in terms of bracket or sketch. Next, what happens when you differentiate these signals and integrate these signals? For example, if you integrate an impulse function, you go to a unit step. If you differentiate a unit step, you get back to an impulse. What happens if you integrate a unit step? You go to a ramp, and then when you differentiate a ramp, you get back to a unit step. Or it might be a gate, depending on where the ramp starts and ends. So differentiating and integrating signals, we looked at that next. We did some homework problems, we did some class examples. We looked at discrete time signals. How do we define that as a sequence? And the underscore was used for n equals 0. Um, we defined some common signals even for discrete time, which are very similar to the step, ramp sequence, gate sequence, not gate sequence. We did step sequence, ramp sequence, and an impulse. And then we established the relationships between those three sequences: step, impulse, and ramp. There were some power series equations that were useful in solving some of these problems. Those power series formulae, if I think that you need that for a particular problem, I will cite them in under the problem itself. So you don't have to look it up on the web, right? Which is not allowed. So if I feel like you need to look up the formula for, I equals negative infinity, well, let's do 0 to infinity. 0 to infinity x power I, right? There is a power series for this, provided the magnitude is less than 1. So the whatever power series formula we had, if I think that you need that for a problem, I will give you those formulas in the exam itself. Let's see, system properties is next. We classified systems, both continuous time as well as discrete time systems, into whether they are linear or not. And for linearity, we looked at two things, right? We said homogeneity and additivity. Then whether the system is time invariant or not, whether it has memory or not, whether it is bounded input, bounded output, stable or not, and then of course causal, non-causal, anti-causal classification for system properties. We did examples, you did homework on this. So another, that is the 1, 2, 3, third main topic there. So, I would consider the first over here, the second and the third to be, relatively straightforward. There is not too much intuition going on over there. But as you go on to the next two topics, that's when, your level of understanding, or you know the really how you look at systems, their impulse response, their step response, how do you find out the outputs of systems given an input, all of that is really like the intuition takes a major uh, role as you go to response of linear time invariant systems. So we classify we characterize the linear time invariant systems using its impulse response. We looked at discrete convolution to be able to find the output of a discrete system. We looked at three different approaches: analytical, graphical, and an array based approach. In my questions, if I specifically ask you to use a particular approach, please use that approach. You can use whatever you like to check your work, but if I ask you to use a particular approach, please use that approach. Um, and then we looked at continuous convolution. We looked at the analytical and the graphical method. And these approaches had their own pros and cons. They were suitable to do some convolutions, and they were not suitable to do some others. And then we looked at the superposition principle. So in the superposition principle, uh, this is one example where you can clearly see that the approach you take matters a great deal. What I mean by that is this. So think about, let's see, a system. Say we have a LTI system, and you are given a particular x of t here, and you are given the y of t here, right? And suppose there is a impulse response h of t that characterizes the LTI system. Now, one way to find out x of t, y of t, is to convolve, right? X convolved with h, or h convolved with x, gives you the output y. But it might, in some cases, it might be easier to directly use the superposition principle to do this, right? So for example, if you have, say, you are given u of t goes in, and this is a LTI system with system operator t, you get some y step of t, right? Step response. Suppose you are given that, right? You are given y step of t. Then, if you are given a new input x, which can be expressed as a scaled scaled and shifted versions of u of t. So maybe x of t is, say, m1 u of t minus 2 minus m2 u of t minus 4, right? So in that case, how would you find out the output? Well, one way to do this, or the very long way to do this, would be to take this guy and convolve it with this to get y of t. That could take a long time. Or you might simply write y of t equals, let's see, m1 y step of t minus 2 minus m2 y step of t minus 4, right? You didn't even need to use the impulse response. So that's a very classic classic example to demonstrate that the approach you take matters a great deal, right? Because you might have spent like half an hour, maybe more, depending on what shape, what h of t looks like. You might be spending loads of time doing that. Sure, you will get the output, and it will be correct, but you could have used superposition because this is an LTI system, and you already know the answer. So, I'm trying to encourage a sense of thinking in a manner to simplify your solution, right? All right. So I hope you find that helpful. The next point here under response of LTI systems is the step response. And step response has a direct relationship with the impulse response. If you differentiate step response, you get impulse response. We saw that in the lecture. So once you have the impulse response, then you can use all the other properties to get to the output of the LTI system. Okay. Then, while you're doing convolution, you can leverage on many of these properties. So, for example, convolution with an impulse function is extremely simple because, right, convolution with an impulse is going to give you the same signal, right? X of t convolved with delta of t will give you back x of t. So, convolution with an impulse function, that's a property of convolution, but it is very straightforward. The time reversal property of convolution, the commutative property of the convolution, um, cascade and parallel connections, how are time shifts. So if you shifted your first signal, then shifted your second signal, how would the convolution result shift? So that's the time shift property. Then we looked at three different symmetry properties. We looked at the derivative property. So if you differentiate one of the signals being convoluted, it will mean that the output of the original signals gets differentiated as well. Then we looked at the distributive property for convolution. So try to use these properties to make your math that goes on over here or here become very easy. So, before you jump into the convolution integral, just, take a moment or two to see if there is a, property that you could take advantage of. So, that few minutes that or, few moments that you spend before you actually, jump into rigorous integrations, those few minutes can help you save a lot of time. Okay, let's see. That's essentially what I had planned, you guys. Okay, so let's see here. This is